And now the floor is open for discussion on marine heat waves, both from the online participants as well as.
Thank you very much. Yeah, they were both very interesting presentations, all three of them on the marine heat waves, which has also been a very intense topic in Australia for the last few years, of course. My question is to the second speaker, to Brenna. In your next steps, future directions, you said that you were going to look at the use of higher resolution like SST data set. Which, have you started to look at them? Have you started to consider what you might use?
Thank you, Helen. Yes, we are starting to use the OSTRA, and we also look at the MURSST by the NASA, and we found that they are more effective in detecting marine heat waves, especially in the coast. And there are actually more marine heat waves that we detected using those higher resolution. But then there are still some requirements that we'd like to meet. For example, the period of the SST or the historical data that we have to use, it has to be longer than 30 years.
Yep, that's right. Yes, yes, Ostia is a really good product in that it does resolve features really well, especially if you use the reprocessed version 2 product, which goes from 1981 through to mid-2022, I think, and then you can update it with the real-time product. But you may have seen the presentation by Owen Embury earlier this week. Owen Embury from Reading University about the CCI version 3 reprocessed product. It's very exciting that it now goes back even earlier.
Yeah.
So 1978 or something? Where's John? 79, yeah. So you can add 2 more years, and it'd be nice to see how that performs close to the coast because it's a new product. Be nice, you know, it might be good to take a look at it too.
Yeah, thank you. So we were actually discussing at that one the previous days. So we would like also to explore that data set, especially that I think it's level 4, right? Oh, is it level 4?
Oh yeah. 0.05 by 0.05 degrees lat and long. It's the same grid as Ostia, and it uses reprocessed, recalibrated satellite SST data sets that John is involved with, so you can ask him any questions about it. Not me, it's not my product. Talk to John.
Yeah, thank you so much, Helen.
Good morning. My question to Brenna again. Thanks for your nice presentation. Somewhere in your presentation you mentioned that there had been 75 events that you have observed. So did you look into that? What is the time span of these events? Like what's the minimum and the maximum and the average over the time?
You mean the 75 events that I mentioned that occurred in the last 20 years?
Right.
So it is, yes, as I mentioned, the last 20 years. So it's from 1998 to 2021, around that time.
No, that's okay. Like what is the span of these events, the spells?
The span? You mean the duration?
Yeah.
Oh, yeah. So for the duration, fine. So for the duration, it's actually more on the 75 to, as I've mentioned, we reached even 276 days in 2020. So it's around that range.
Okay. Thank you.
Thank you.
Good morning to all the offline and in online participants of the workshop. I have two comments for discussion. Point number one is in the over the land, we compute the heat wave conditions at 2 meter height, but in the ocean we are directly going to the sea surface temperature instead of taking 2 meter height. And what will be the conditions? How the conditions will change if you take the how the conditions will change if you consider the temperature 2 meter height temperatures we consider. That is point number one. And in over the land, we also use the heat stress, including humidity factor. So that is found to be more effective than heat conditions. So similar thing can be done over the marine heat stress or heat like marine heat waves, marine heat stress also can be included. And the last point is we observed that changes frequency in the changes of sea surface temperature is very high compared to the ocean heat content. And for example, in the third speaker who mentioned that she mentioned a difference between the marine heat wave in the upwelling region and non-upwelling regions. If heat stress is ocean heat content is considered, this difference is mostly likely to vanish. So these are my 2 points. If somebody can discuss on that. Thank you.
Yeah, thank you so much for that, sir. So I think you also pointed that out during my poster session. So yeah, I think we'll consider looking into the temperature at 2 meters. And for the ocean heat content, as I've mentioned, part of the limitation of my study is that we strictly follow the proposed scheme by Habde et al. And so we'd like to also explore the ocean heat content because we're also looking into the coincidence of marine heat waves with intensification of tropical cyclones. So it's actually part of our future activities. So thank you so much, sir.
Yeah, is there anyone to comment on this question online?
Yeah, I have a comment, not question. So it's good to see 3 different approach for marine heat wave monitoring tools, sort of thing. So my point is, by doing all these things like detailing climatology or the looking at the ocean heat content or the studying the relationship with the winds and all those things, whatever the results we are getting, if we are comparing them with the biological information, so what actually happening means, was there fishing die-off events or the migration of the fish or something like that. If we can combine that information, that could work sort of validation of our results.
Well, for me, for this project, we, as I mentioned, we are focused on detection only, but we have also observed a jellyfish bloom that coincided with a severe marine heat wave in the Philippines. So it's in the western part of the Philippines, and my colleague actually found out that it contributed to the bloom of, yeah, the jellyfish or Mastafara species, and it caused economic injuries, of course, for the tourism and for the fishers. But as of, you mean the management or the strategies needed, or what we can recommend for like the management side, I could not answer that with full confidence at the moment because we have not yet dwelled into that kind of study.
No, that's completely different. I'm not talking about management or anything. I'm just talking about just using that biological information as the validation. And it wasn't only pointing to your presentation, to a general comment. Thank you.
I just wanted to say as well, it's a really important question, and that was something we were looking into if I was going to extend this master's into a PhD. into looking like if we can correlate any of these events with marine impacts. I know there's been a lot of work in marine biology looking at like temperature, thermal fluctuations and how that affects fish. I know they're doing a lot in tropical regions. I haven't seen any in cold water regions where like kelp die off, and change in kelp, but that would be definitely something that we should look into.
Yes, just some comment from my side. It is surely important to extend the assessment of marine heatwave, also considering the depth temperatures other than the sea surface ones, and because as I've shown in my presentation, the worm anomalies that penetrate in the depth can persist because the mixed layer, for example, in the Mediterranean Sea, can persist inalterated for until winter. So in practice, this blob of warm water in practice remains remains unchanged, do not propagate, and then can enhance the evolution of successive marine waves. And it is also important to study biological impacts, and in a current project dedicated to marine waves, which is funded by ESA, my colleagues are studying data from BioArgo in order to analyze eventual correspondences between what happens to, for example, chlorophyll during these events.
There is a question online from William Skirving.
I think it's extremely important to not create a metric, which is in effect the way that Alistair Hobday created the marine heat wave, and then go hunting for uses for it. It's better to ask yourself what you want to do and then create the metric to fit it. At Coral Reef Watch, we have been doing sea surface temperature anomalies for well over 20 years now, and haven't really had a use for them other than to inform us on how the physical world is behaving at a particular time in the year. A marine heat wave, as defined by Hobday et al., and I might add we've got a product as well that is a marine heat wave according to Alistair's definition, is really just a sorry, my brain's gone blank. It's a categorization of the sea surface temperature anomaly product. The products that most people use from us, well, not most people, almost all people use from us to look at effects on marine organisms are fundamentally different to those marine heat waves. So the marine heat waves that have been talked about today have all got a varying climatology through the year. So in the winter time, the climatology is lower than it is in the summer. Most organisms, we can pick on coral reefs if you like, are very happy to have warm waters. In fact, quite strong marine heat waves during the winter, and they'll be very happy. But you can't have a strong marine heat wave during the summer. So what you've got to do if you want to link it to an organism, in particular the flora, you've got to understand the thresholds that trigger stress. And those thresholds won't change. So having a changing climatology doesn't suit that purpose. Even when it comes to the fauna, it's true. It may well be that a lot of these marine heat waves will trigger behavioural changes. But even then, it'll probably be a static threshold. I mean, for instance, tuna like 28 degrees, and they look for 28-degree fronts. If those fronts move because of the marine heat waves, then so will the fish. So all I'm suggesting is that it's important to ask what we're trying to, what phenomenon we're trying to understand in the biological world, and then understand that phenomenon, and then go and build a product, as opposed to the other way around. I think marine heat waves are a great tool, but they tend to only, I believe, tell you about the physical environment rather than the biological environment, or biological impacts, I should say. That's my comment.
Thank you. Any